Okay, so we're going to talk a little bit about order of operations. If you've ever seen order of operations, it's pretty dumbed down. They use PEMDAS, and basically what PEMDAS is parentheses, exponents, multiplication, division, addition, subtraction from left to right. That's the direction you're supposed to do these things. However, PEMDAS is great if you are just kind of going through the motions. You don't really care what's going on. But let's actually explain why. And to explain why, we kind of have to understand what all these things are. We'll start off with addition and subtraction. Now, the way addition and subtraction works is it works off the idea of a number line. Now, if you've seen a number line before, great. If not, basically, this goes on forever in both directions. It involves every number that could exist, whether positive or negative. But it basically has them all. Now, basically, when I have addition, let's say I have 2 plus 2, right? Well, I start at 2, and then I go up 2 more places. So 1, 2 more places right here, ending up here. So 2 plus 2 is just, in this case, 4. 2 plus 2 is 4. That's how addition works. Subtraction is very similar. Let's say I have 1 minus 3. So we start off at 1, and then we're going back 3. So here's 1, 2, 3. So we're going from here to here, bringing us at negative 2. So that's the way that you should always think of addition and subtraction. Now let's talk about what multiplication and division are. Now multiplication how long it takes to write multiplication. Multiplication is actually just a system of additions with a few very specific exceptions. For instance, multiplying by 0, doing a negative times a negative. Those two are very unique exceptions. When you multiply by 0, it's always 0. However, when you multiply a negative by a negative, it becomes a positive. So it actually depends on how many negatives you have, because you can multiply long lists of things, right? And as long as you have an odd number of negatives, it becomes a positive. If you have an even number of negatives, it's a positive. If you have an odd number of negatives, it stays negative. But anyway, multiplication basically states as follows. If I have 3 times 4, you can think of this in 2 ways. You can think of this as 3 plus 3 plus 3 plus 3, or 4 plus 4 plus 4. Either of these would basically be the same. 3 4 times or 4 3 times. That's the basis of multiplication. If you think about it, you're just adding up a bunch of things, except we're just doing it all at the same time. And so instead of writing all this out, which is quite a pain, we just do multiplication instead. Which is why it becomes quite simple when we are doing long multiplication. It makes it a lot easier to do that. Whereas division, and we're not going to write it out this time, division is basically a little bit different. So if I have, let's say, 10 divided by 2. Now this one is different because we're seeing how many times let's say I have 10 of something and I'm dividing it into 2 piles. So basically, when I take 10 and I divide it by 2, I take 10, let's say, I don't know, little circles. It'll make this easy So if I have 10 circles and I'm dividing them among 2 people, each of them would get 5. That's how division works. This is basically something that cuts it into pieces. And if you've seen my section on simplifying fractions, this is just basically a fraction, right? So how many different ways can I fraction this out, right? Well, I'm just breaking this into 2 different pieces. Now, sometimes that doesn't work. Sometimes you have something like 13 divided by 2. Well, that one won't work. It'll become some sort of different sort of fraction because it doesn't break up nicely. But you can cut things in half, cut things in thirds, so forth, so forth. Sometimes you can do that for an eternity, which is why you'll often have repeating decimals. I think a good repeating decimal that just pops in my head really easily is 22 divided by 7. That one I don't think ends. It just goes on forever. And it also gets really close to pi. I think that's why I remember it really easily. But that's division for you. So we got multiplication, we got division. So why are these two similar like addition and subtraction? By the way, as far as PEMDAS is concerned, if you switch the A and the S or the M and the D, you're not going to really change things. If I have 3 times 2 divided by 3, and I decide to take 3, or I can multiply these two guys together first, giving me a 6 divided by 3, which gives me just a 2. But if I switch this around a little bit to 2 times 3 divided by 3, if you notice 3 divided by 3 is just 1, 2 times 1 is also just 2. So it doesn't really matter what order you do multiplication and division. And the same with addition and subtraction. For instance, if I have 3 plus 4 minus 2, right? I can do 3 plus 4. 3 plus 4 is 7. 7 minus 2 is 5. However, if I take 4 and I minus 2, I have 2. And 2 plus 3 is also 5. So either way, you're going to get 5. It doesn't matter in what order addition and subtraction or multiplication or division go, because they're very similar in a lot of ways. Let's talk about exponents. Why do exponents become before multiplication and division? Well, if we think about addition and subtraction as just a longer form of addition, or multiplication and division is just a longer form of addition or subtraction in this particular case, then exponents are also very similar in that it is a higher form of multiplication. For instance, if I have 3 to the 3rd power, that's just 3 times 3 times 3, right? And you could write that out all in addition and all sorts of things. It can all continuously break down into its base format. But that's what exponents are, which is why we do exponents first. Because let's look at this. If I take 2 times 3 to the 3rd, by the way, 3 to the 3rd is 27. So I got 27 times 2, right? Well, 27 times 2 is going to be 54. Whereas, on the other hand, let's say I multiply it first. What's 2 times 3? Well, 2 times 3 is 6. So what's 6 to the 3rd? Well, 6 to the 3rd is 6 times 6 times 6. And you should start to, if you know anything about multiplication tables, start to be pretty worried about that. Because 6 times 6 is 36 already. And if you multiply that by 6, let's go ahead and do it real quick. So 36 times 6. So we got another 36. We got 18, 19, 20, 21. 216. So you can tell there's definitely a big difference between these two answers. You can't multiply before you raise to the powers. So raise to the power first, then multiply. And that's the reason why, because they're very different. Now I want to show you a trick. If you have 2 times 2 to the 3rd, you can actually simplify that down into 2 to the 4th. If these two numbers are the same, you can actually put these in here, but it doesn't multiply this guy, it just adds to this number. Because think about it, that's how many times 2 are multiplying, and I'm just multiplying another 2 into there. So that gives me 2 to the 4th, which in this case, let's see, 2 times 2, let's see, 16. That's just 16. So there we go. There's our answers there. So that's why that happens. Now parentheses. Why do parentheses come before anything else? Parentheses come before everything else. And we're going to switch colors here. Why are parentheses the top dog? Parentheses are the top dog because we needed something to basically filter stuff out, right? Because let's say I was raising something to the power of 3. And let's say it was 2 plus 2. Oh, well, exponent should come first, right? No, not this time. Parentheses come first. Everything in parentheses comes first. Now, there's a lot of reasons for that, but basically, just think about parentheses is always the first thing that's going to happen. Always the first thing. So 2 times 2 is 4. So this becomes 4 to the third. Let's see. So it's 16 times. That's 64. There we go. So there we go. That's what this one becomes. But is that the only way to do it? And this is where it starts to become tricky. Because if you notice parentheses here, all of these things, everything can break into parentheses except for addition and subtraction. So what does that mean? Well, let's take this and think about this real quick. So this is 2 to the third plus 2 to the third. 2 plus 2 is 4. 4 to the third. I got to rethink about this. 16 times 4 because it might be a little bit high there. It's been a while. 4 times 6, 24. No, it's 64 for sure. So if I raise both of these to the third, now that still doesn't work. Now the question is why? And that's because all things considered, addition and subtraction are very unique. So you might be thinking, well, this is going to work, right? 2 to the third times 2 to the third. Well, no, because 2 to the third is 8 plus 8, which is just 16, so we're short. So the question is why? Well, if things can break in here, right, you can break into things as long as you're only 1 degree below. So what do I mean by that? Well, let's check this out. So if we're doing this correctly, 2 to the third times 2 to the third, right? Well, I can just add these together and make it 4. However, that's not the only way I can do this. I can do 2 plus 2 times 2 plus 2 times 2 plus 2, right? But if you notice those are just all 4s, that's just 4 to the third. So you can't pop that in there. However, it changes ever so slightly, and we'll change the color here. If this had instead been 2 times 2. And so let's look at what would change there. So this would be 2 times 2 to the third. So what would change here in this one? Well, if we look back here, this would change from 2 to the third plus 2 to the third to 2 to the third times 2 to the third, which is 8 times 8. 8 times 8, we all know, is 64. Get rid of that real quick. So you can kind of see the difference here. You can break this into something. Basically, you can break into a lower level as long as the parentheses allow. Let me give another example here. Otherwise, we have to do some very unique things. If I have an addition, let's say 2 plus 6, and I have a multiplier outside. Now 2 plus 6 is one slot lower. So can that 3 go in there? The answer is yes. These can multiply here. So first of all, what is 2 plus 6? 2 plus 6 we know is 8, so this becomes 3 times 8, which is just 24. However, if I do 2 times 3, which is 6, plus 3 times 6, which is 18, it also equals 24. In other words, there are a lot of different ways to do mathematics. This right here is great, but it's more of a suggestion than actuality. So we love PEMDAS, we love what it represents, we love the idea of it, but there are always more than one way to do any one problem. As you can see, you can always break things apart. You can always do things slightly differently. And the problem is that this is very rigid. And I want you guys, when you're doing mathematics or anything of the sort, I want you to consider this not to be a rigid system where you always have to do one thing before you do another, every single time. Not always the case. There are some things that are pretty well spelled out, right? Like if I have 3 times 2 plus 4. I cannot add that 4 first. 3 times 2 has to come first. But once parentheses get in there, it becomes more of a suggestion than anything. And that is where the problem lies, because you got to really have some nuance in your mathematics, and you have to really open up your brain in order to be able to think about different ways to solve problems. There are always different ways, and I don't want you to ever think that you need to be stuck in a very rigid format, because if you're always stuck in that same rigid format, eventually a problem will come that it doesn't want you to solve it in that rigid format. It wants you to solve it somewhere else. And we haven't even started talking about variables yet, and variables are just a value that we just do not know the value of, right? And I think maybe I'll save that for our next video. But I think for this, it's a suggestion, but a good one. A good suggestion. Very good suggestion. Because it works out pretty much every time. If you're always following this, you'll always be good. I'm not saying that you have to follow it to 100%, but knowing all the rules so that you can solve it in 2 different ways will make a huge difference, especially when we get to the point when we just throw in variables. So I hope that helped, and yeah, hope to, if you have any questions or anything on this, just feel free to look through my other videos and send me or write down a message in the comments. Have a great day.